Everyone, welcome back to another session on Seneca Learning. Today we're going to be going over electrolysis for chemistry GCSE. It can be quite a complex topic. There are lots of keywords, so I'll go over them a bunch of times to help them stick. So let's get started. What is electrolysis? Basically, it's just a process that splits ionic compounds into their constituent elements. And when an ionic compound is melted or dissolved in water, it means that the ions that make it up are now free to move around. And ionic compounds that dissolve in water to make a solution are called electrolytes. And you might see that word on stuff like Lucozade bottles or sports drink bottles because they're full of electrolytes. Let's go on to some more keywords that we're going to come across. One is cathode, which is a negative electrode, and anode, which is a positive electrode. So a cathode is a negative electrode. Do we think that positive or negative ions are going to go to it? It's going to be positive ions, because positive ions or cations are going to go to the negative cathode. Similarly, at the anode, which is going to be the positive electrode, negative ions or anions, they're going to go to the anode. Cool. So what happens when the ion reaches the cathode or the anode? Basically, the ion can receive or donate electrons. So if we take the example of copper is a positive ion, so it is a cation. It's going to go to the cathode, which has a negative charge, and it's going to gain 2 electrons to form copper metal. And that's what happens during electrolysis. So let's continue going. Let's review all of the key parts of an electrolysis apparatus. We have the 2 electrodes. Do you remember what the positive electrode is called? That's an anode. And the negative electrode, that's our cathode. And basically we submerge them in an electrolyte. Do you remember what an electrolyte is? That's just an ionic compound that will produce ions when in solution. So if we take the example of copper and we put it in a solution, it's going to move to an electrode. If its copper ions are positive, so which electron is it going to move to? It's going to move to the cathode, because the cathode is negative. And it's going to gain some electrons. Does that all make sense? I think so. It's all good. So let's go over ionic compounds outside of a solution, because ionic compounds don't have to be in solution to conduct electricity. We can also melt them, and when we melt them, we say that they're molten. In a molten ionic compound, the ions are free to move around, and that liquid, the liquid produced by the melting ionic compound, can undergo electrolysis. Good thing to remember, metal ions are always positive and the non-metal ions are always negative. So if we take the example of NaCl, which is just table salt, the Na ion will be positive, Na+, and the Cl- ion, the non-metal ion, is going to be negative. Awesome. Let's do a different example. What would happen to copper oxide if it underwent electrolysis? What ions would we produce? We're going to produce Cu2+ and O2-. The Cu2+ ions, they're positive, they're going to go to the cathode. O2- ions, they're negative, they're going to go to the anode. Now, this is an important point. When the oxygen atoms get to the anode, they're going to donate electrons, and they are going to form oxygen gas. So the anode will see some bubbling. Boom. So do you remember the different names for the ions? So a negative non-metal ion, what is that? It's an anion, and they're always attracted to the anode. Awesome. Electrolysis, what's the point of electrolysis? Why do we do it? Well, it's really useful for extracting metals. So when metals are dug up from underground, we get a metal ore. And an ore is just like a mixture of a bunch of random metals, and we need to purify it. So one thing we do this a lot with is aluminum. At the anode, the positive electrode, oxygen forms and we get the bubbles. And the anode is normally made from carbon because it is a good conductor and it's also cheap. At the negative electrode, that's where the metal ions from the ore go, and that's where the aluminium is formed. And it's a really good process, but it's very expensive. And why is it expensive? We need a lot of energy because we have to melt that metal. It has to be molten, so it's going to be very expensive because energy isn't cheap. And that's the main reason why it's expensive. So let's recap quickly. If we are doing the electrolysis of aluminium, what happens at the anode? That's where the gas is going to form, so carbon dioxide will form, and at the cathode, aluminum will form. So the metal always forms at the cathode. So to recap, when a voltage is applied across an electrolyte, the charged ions are attracted to the oppositely charged electrode. So voltage, make sure you spell it correctly, is applied to an electrolyte across an electrolyte. The charged ions are attached to the oppositely charged electrode. Amazing. And electrolysis, we have to use it for metals that are more reactive than carbon. If it's less reactive, we have to use something like copper. And quickly, what are the names of the different electrodes? The negative electrode, that's going to be the cathode, and the positive one, what was that? The anode. Amazing. So that just about covers everything we need to know for electrolysis. So I hope it was useful. It is a big topic. There are lots of keywords, so hopefully this was a good foundation. There is going to be a part 2 to this episode, electrolysis 2, so make sure you check that out. Other than that, hope this was useful. Catch you on the next episode. Cheers.